Uh, I'm getting so many wishes on the occasion of Teachers' Day. So, thank you, those who wished me for Teachers' Day. Thank you very much. Here, next thing, so related the arithmetic progression, I'm going to take the next how to add the sum of the terms of the arithmetic progression. You know that one arithmetic progression definition. A progression is said to be an arithmetic progression if the common difference between n two consecutive terms is same, or a sequence in which preceding term and next term whose difference is what same, then what to call that as a arithmetic progression. If we add the terms of the arithmetic progression, what to call that as a series. Here, how to add the terms of the series? Okay, let us think about that. Here, first thing, that's what how to add the sum of the natural numbers. How to add the natural numbers. Natural numbers. You know that one. Natural numbers means what? Common difference is same. That is equal to what? 1. Example, you may take 1, 2, 3, 4, 5, 6, like that. Here, common difference of what? 1. How? The 2 minus 1 is equivalent to 3 minus 2. It is equal to what? 1. Here, common difference of what? Same. That is what equivalent to 1. Here, for this natural numbers, you have to develop the one relationship. Here, derivation is very important. You should know that. Here, observe that carefully. Here, I am going to take sum of the 6 terms. Sum of the 6 natural numbers means 1 plus 2 plus 3 plus 4 plus 5 plus 6. Here, 6 terms taken in the natural numbers. To develop the relationship, okay, I want to write this in the reverse order. That is S6 is equivalent to 6 plus 5 plus 4 plus 3 plus 2 plus 1. Here take this equation 1 and take this equation 2. Adding both the equations, here what thing obtaining? S6 and S6, these two are the variables. 2 times the S6, adding 1a plus 1a, 2a, 1b plus 1b, 2b, 1c plus 1c, 2c, like that only it is added. That is what S6 is 2 times. So by adding, you are getting the thing 2 times the S6. It is equivalent to. Here adding 1 plus 6, that is 7. Adding 2 plus 7, 2 plus 5, 7. Here adding 3 plus 4, 7. In the same way, here also obtaining 7, here also obtaining 7, here also obtaining 7. Here 7 is how many times? That depending upon the number of terms taken. So that is 6 times it is. Here 2 times the S6 is equal to what? That is 6 times the 7. Okay. You may reduce 2 ones, the 2 threes, the sum will be what? 3 sevens, the 21. That's okay. That's not the case here. You need to develop the one relationship to find the sum of the arithmetic progression in which a common difference is equal to 1, then nothing about natural numbers. Here 2 times the S6 is equal to what? 6 times the 7 can be written as 6 times the 6 plus. It's okay. Sure, you may write. Here 2 cross multiply into sign is there. So for that purpose S6 is equal to what? 6 times the 6 plus 1 divisible by what? 2. Here this is the what for six natural numbers. How to find the sum? Suppose 7 terms are there. Then what would write written as 7 times the 7 plus 1 divisible by what? 2. Suppose there are 8 terms. Then how to write that as 8 times the 8 plus 1 divisible by what? 2. Here I want to develop for finite terms Sn. So Sn is equal to what? Here in place of 7, 8, n, dot, 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 ended by n. Therefore, in place of this, what are n times the n plus 1 divisible by what? 2. So this is the one formula to find the sum of the what? Natural numbers. What that sum of the natural numbers? Sn is equal to what? n into n plus 1 divisible by 2. So you have to keep in your mind. In certain cases, instead of for natural numbers only, to find the sum that represents about sigma n, sum of the natural numbers. Here, the same case, right side, n into n plus 1 divisible by 2. Okay, you may use any one of these two. Sn means sum of the finite terms. Sigma means summation of the finite terms. Okay, both are correct. Right is what? N times the n plus 1 divisible by 2. Okay, it is easy to remember. Here, what to develop this formula? Common difference is exactly equal to 1. In case of natural numbers, common difference is what? 1. This formula can also be used for multiples of 2 or multiples of 3 or multiples of any number. There also you may use this formula. Okay, so these are the main points you have to keep in your mind. Suppose next thing, common difference is more than 1. So which relation you have to develop? So for that I need a general example of arithmetic progression. Here what that general example of arithmetic progression? You know that one. A plus D, A plus 2D and A plus 3D. So this is the what? These are the what? Terms of the general example of arithmetic progression. Here A first term, D that is the common difference. I want to add those terms. So for finite terms, you know that one. That is to find the sum of the finite term. It is taken as what? A1 plus A2 plus A3 plus dot 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 plus AN. AN means what? Finite terms. Okay. Here, one thing you should keep in your mind, n is any term. Its next term is what? An plus d, common difference added. To get the next term, common difference is added. Suppose you need previous term, then common difference subtracted from an. That's what an minus d. So these three terms are very important. Any sequence an, if you need next term, common difference added to that what term an. Suppose you need previous term, okay, or preceding term, common difference subtract from an. So in that way, you have to think about the what next term and previous or preceding term. Okay. So now here I want to take what that that is Sn is equal to what? A means first term A only. Second term, that's what? A plus D. Next, third term, that's what? A plus 2D plus dot 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 dot. An means plus A plus n minus 1 into D. Okay. So take this as equation 1. So what are the sums to be added? A plus A plus D, A plus 2D, dot 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 dot, plus A plus N minus D. Here I want to assign A plus nth term as what? Last term. So that is taken as what? L. L is nothing but what? Nth term. Nth term nothing but what? A plus N minus 1 into D. Okay. It is easy to remember. Okay. So don't show any type of the effort for this. Here I want to take Sn is equal to what? A plus D, okay, plus A plus 2D plus dot 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 dot. So here L is the what? Last term. Its previous term L minus D plus L. Okay. So take this equation 2. Here very simple. So in place of an or a plus n minus d, what have taken? L for last term. And don't forget this nth term that represents not only the nth term, last term also. So on that basis, I have written Sn is what? A plus d, a plus 2d plus dot dot dot, L minus d plus L. L means what? Previous term of L. I told if you need previous term, subtract common difference from the given term L. Okay. Here I want to write this equation 2 in the, it is in the increasing order. I want to write this one in the decreasing order. Decreasing order what? Here L, its preceding term is L minus D. Its preceding term is L minus 2D plus dot 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 plus A. Okay. Here I want to add these two equations. What we did for to develop the relation for natural numbers. Here's the same thing. Here 1 1 Sn that become what 2 times the Sn. It is equivalent to L plus here plus D minus D cancel. So here adding A and L. What are you getting? A plus L. Both are unlike terms. So unlike terms cannot be added. So for that reason A and L adding what are you getting? A plus L. Here plus D minus D cancel. So what thing obtained? Here A is left, here L is left. So that is what A plus L. In the same way, plus 2D minus 2D cancel for third terms. So plus, here what that? A plus L. Okay, my dear children. So plus dot dot dot. In the last, L and A adding. Okay. So what are getting? A plus L. Here A plus L is how many times it is? That is n times. So for that purpose, I want to write this one as about 2 times the Sn is equal to what? N times the A plus L. I need to find the sum of the finite terms. So for that purpose, here 2 into is there, cross multiply. Then Sn is equal to what? That is n into A plus L divided by what? 2. So this is also one type of the relation. So take this in equation 3. Here in a series or in a sequence, so first and last terms are given, you have to use this. But if you are going to use this, you need to find the what? Number of terms. So I will show the one example. Sn is equal to, I want to add the odd number terms. 1 plus 3 plus 5 plus dot 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 plus 51. Here 15 is a term, don't forget. In that situation, after finding the number terms in this sequence, so you may use this formula. Okay, so I told the reason when should you use that one. Now, in place of L, I want to substitute L is equal to what? An plus A plus N minus D. So here put, so L is equal to what? That is An is equal to what? A plus N minus 1 into D. So substitute in this equation 3. Then Sn is equal to what? N write as it is by 2 here. Inside the bracket A, okay. L means what? A plus N minus D. A plus n minus 1 into d, close the bracket. Here 1a, they are the like terms, you may add n by 2 is equal to about 1a plus 1a, 2a plus n minus 1 into d. So this is the final formula. Take that as equation 4. So this is the formula can be used when the common difference is what? More than 1 and common difference is given. In the situation you should use this formula. Okay. So what is the formula? Sn is equal into n by 2 of 2a plus n minus 1 into d. Okay. Here n is the what? Number of terms in that given AP. A is the what? First term. Same, n is what? Number of terms. D is the what? Common difference. Here, don't forget. So, how many unknown elements are there? A is there, N is there, D is there, and S is there. 4 unknown elements. Out of those, 2 or 3 terms are given. So, you may find the what? Other one or other 2. So, anyway, today we learned two formulae development. So, first one is what? For natural numbers, common difference is 1. So, what the formula? Assume what? N into n plus 1 divisible by 2. Suppose common difference is more than 1. Okay. So, what is the formula you use? Here, things are two relations obtaining. Sn is equal to what? N into a plus L by 2. Next is what? Sn is what? N by 2 of 2a plus n minus 1 into d. Here I repeat the development of this formula. Here what that taken general example of arithmetic progression is taken. A plus d, a plus 2d, a plus 3d dot dot dot. Here for finite terms how to add a1 plus a2 plus a3 plus dot 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 plus an. Here one thing you have to keep in your mind, if any term an, its next term is what? An plus d. That is nothing but common difference is added to the given term. Suppose if you need previous term, so common difference subtract from given term. Here Sn is equal to a plus d plus a plus 2d plus dot dot dot. Last term, nth term taken about a plus n minus into d. Here n is not only nth term, but also last term. So I took L is equal to what? A plus n minus d. Then what thing happening? So Sn is equal to what? A plus d, a plus 2d plus dot dot dot. L is the last term. Its preceding term is L minus d. Its next term is L plus d. So but anyway, don't take next term. So preceding term L minus d only to be considered. So write this in the reverse order. This in the increasing order. Now I am going to write in the decreasing order. L, its preceding term L minus d, its preceding L minus 2d plus dot dot dot. Here last, first term is what? E. Now adding that equation, these two, 1s and 1s, that become 2 times Sn. L, they are the unlike terms. You can't add, keep that as binomial a plus L. Here plus d minus d cancel, again a plus L. Here plus 2d minus d cancel, again you are getting a plus L, plus 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 plus. In the last, adding L and a, again a plus L. How many times it is? That's what? N times, that depending on number of terms taken. Therefore, 2 times the Sn is equal to what? N times the a plus L. To cross multiply, then Sn is equal to what? N times the a plus L by 2. So this also a formula we can use while solving the problems. In what situation? Suppose finite terms are given, first term, last term is given. This is one counter example I have taken. So 1 plus 3 plus 5, sum of the odd numbers. Last term is plus 51. Here first we have to find the number of terms, how many here. After that, you may use this formula. Next, put L is equal to what? Is equal to what? A plus mcd. Means last term or nth term is what? A plus md in this formula. Here Sn is equal to n by 2 written. A is written. In place of L, what is taken? A plus n minus d. Then what that 1a plus 1a, that becomes 2a. Here n minus 1 to d plus n minus to d. Therefore, you have to apply one fine formula to find the sum of the arithmetic progression whose common difference is more than 1. What is the formula? Sn what? N by 2 of 2a plus n minus 1 d. Here n means number of terms, a means first term, d is common difference, Sn means sum of the finite terms. Okay, my dear students. So you should learn the derivation of each relation. So very easy to learn. So you have to feel this derivation. These are the derivations are very easy. Surely you can understand and you can keep those permanently in your mind. Okay. Thank you, my dear students. Thank you, my dear children. So for listening my class and also attending my class. Thank you, one and all. Bye. See you. Don't forget to subscribe my channel and like. Suppose if any type of the comment, you may write the comment section. Bye. See you in the next class.